Hello, welcome everyone. My name is Leela and I'll be your moderator today. Thank you so much for joining us here at NetCom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's webinar, The Essentials of CCNA Master the Latest Principles. And presenting today's topic is Azeem Ahmad. Azeem is a Cisco Authorized Instructor with over 10 years of experience within enterprise network systems. With over 10 years of experience, he has strong analytical skills and a solution-driven focus to improve operational efficiencies and customer satisfaction. Having trained thousands of professionals in areas of routing and switching, security, SD-WAN, firewall, etc., and one of the main differences to Azeem as an instructor is being able to bring his own field experience into the classroom and give his students a feel for real-world examples. Now, please bear in mind that this is just an overview of a very robust topic, and we do offer a collection of technical and business courses that can be tailored towards your specific requirements. If you're interested in a further discussion about any of those, you can make an appointment with our learning consultants through our website at www.netcomlearning.com. Today's session is also being recorded, so you will get free access to the recording in the next 24 hours via email. NetCom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adopting change, and driving growth. And we do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We have 9 practice areas in which we specialize, and they encompass people, process, and technology training. Today's presentation is from the networking practice area. NetCom Learning offers a comprehensive training portfolio for networking classes, and our upcoming classes include various trainings on Certified Network Associate (CCNA) certification, implementing Cisco SD-WAN solutions, and many more. And private training to teams is also available. Those learning plans can be customized to the specific needs of those audiences. You can also access a variety of network marketing assets, such as the free 1-hour training, free on-demand training, and blogs by clicking on the available webinar handout. And these offerings can also be found with a simple search on our website at www.netcomlearning.com. In this webinar, we will learn how to validate our skills in networking fundamentals, automation, IP connectivity, security, and many more. Now, I'm just going to give you a quick overview of the logistics before we do get started today. To start with, you have the option to adjust the window size to your liking. Simply hit the escape key and find the Zoom button on the top left corner of your GoToWebinar viewer. Everyone has been muted except for our presenters, but you can feel free to submit any questions you have for the presenters in the questions panel, and we will address them at the end of the session. Also, to get the best out of today's presentation, we have included the slides, courses we've talked about, and marketing assets in the handout section of your GoToWebinar viewer. You can refer to those to get a better understanding of the topic. And now I'm going to go ahead and pass the time over to Azeem to present for us. I'm making you the presenter right now, and you should be able to share your screen.
Thank you so much, Leila.
Thank you for joining us.
Thank you for having me here, and welcome all of you to the webinar. The Essentials of CCNA Master the Latest Principle. The agenda topics that I'm going to walk you through is, as you can see here, networking basics, internet protocol, IP connectivity and services, security, automation, and programmability. And then we'll be looking at introduction to the local area networks, exploring the functions of routing, troubleshooting, system monitoring, and managing Cisco devices. As Leela rightly mentioned, followed by question answer session. So the network at the most basic level can be defined as having 2 or more devices connected together using some medium here. That medium could be wired medium or wireless medium. As long as two or more devices are connected together, that's called a network. Networking is communication between these two connected devices. The same way we can define internetwork, that means connection or interconnection of two or more networks is called internetwork, and the communication between those interconnected networks is internetworking. Now, when we look at the enterprise network, we know that there is a need to carry data in many types of environments, including homes, small businesses, large enterprises, and there is a need to transmit the data from one location to another location. As you can see here in this picture, that we have got the main campus network, the home local area network, and the mobile users, the roaming users, maybe the employees, their profile is roaming, always roaming from one place to another place, or any branch that you have here. So all of these different types of locations, based on the business of the enterprise, they need to be connected together, and then they need to transmit some data from one location to the other location, right? So that different locations, when they connected together, that's where we are forming wide area network connection, as you can see here, right? So that's the introduction to the networks here. While we are talking about the enterprise network, the characteristics of a network must be something that we should be always considering, out of which the topology and the others given here are going to be very important. So topology is basically going to define the arrangement of the different elements of a network, how they are arranged together. Topology can also be divided further into two categories: the physical topology and the logical topology. The physical topology means that what is the physical skeletal, the way the devices are connected or cabled together, while the logical topology means that the what data flow gonna be there, like how the data being transmitted from source to destination based on the configuration of the network. That's of course gonna be different. Bit rate, that is a measure of the data rate in bits per second for a given link on a device. So let's say you have a router. So what is the data rate at this interface here, which could be, let's say, fast Ethernet 0/1. Is it going to be 100 Mbps or 10 Mbps? That's the bandwidth, right? So that's one of the most important characteristics while you're designing your network, the enterprise network. You need to be taking care about your bandwidth requirements. The availability indicates how much time a network is accessible and operational, which is expressed in terms of percentage of the time the network is operational for. So as I will be explaining here, this is how it is calculated. The availability, where the reliability indicates how well the network operates, basically considering the ability of a network to operate without any failures, as the performance is expected from the network. Both of these can be calculated as for the device, as is given here in the example, that we have got a device X which is rebooting every hour, and the reboot duration is 5 minutes. So using this formula, you can calculate availability and reliability, which is calculated in mean time between the failure. So as you can see here, the availability, it's a total of time in a day in minutes, and then total minutes in a day multiplied by 100. So if you take this example here, it's going to give you 91.67% of that network or a device that's available, and the reliability going to be 55 minutes, mean time between the failure. The same way we got other characteristics like scalability. Scalability is gonna where we are basically indicating how easily the network can accommodate to more users and more data transmission requirements without affecting the current network infrastructure. Right? So if your enterprise network is expected to grow in the upcoming 6 months or on a year, let's say more 5 more branches to be added, those should be supported. And your existing network infrastructures and protocols must support that growth. That's scalability. Quality of service is prioritizing the traffic to basically give it a special treatment based on the criticality of the business traffic that's going on. So based on the type of organization you are, some of the traffic in your organization can be most critical to the business that must be prioritized and must be specially treated. That's where QoS comes in. Cost, that's again one of the most important characteristics of a network. That's gonna basically talk about the overall general expense that includes the initial purchase of the devices or the appliances, then the maintenance cost, the cost to configure it. So it's the overall cost that's included here. Virtualization, as you know that the network services and functions used to be delivered as a hardware solution. But nowadays, at every level, these services and functions are virtualized. They are delivered as a software solution, right? So that's another important aspects of the networks today. Now, talking about one of the mostly talked about protocol, IP protocol, which is the protocol that's working on the internet layer of the TCP/IP stack. As Leela mentioned that in CCNA course, you are going to deep dive into what is this stack, who developed it, what was the need, what were the key drivers. But here, we are just going to focus on the IP protocol. So that's operating at internet layer. It's a connectionless protocol. That means the for the two devices to transmit the data at this layer, they don't need to formally establish any connection first before the data transmission takes place. It's gonna start transmitting the data once there is a requirement by the or from the application. Each packet is gonna be treated independently by the devices. Mainly the device that's working here is the routers or the layer 3 switches that's gonna treat the packets independently with each other. So based on the destination IP addresses, it's gonna basically forward that out based on the best path selection algorithm that's running there. It's always gonna use the hierarchical addressing that we got different classes, different blocks of addresses. That's called IP address, which is an identifier that's used to identify a network device. The best effort delivery of the IP means that it's not gonna provide any recovery features. There is no guarantee to the data delivered. That's a responsibility of another layer at the same stack. That's the transport layer. That's not the topic for today. So it's not going to provide the data guarantee. It's going to try its best for delivering the data. Of course, it's media independent. That means at link layer, what media you are using, that's totally independent on the like it's independent on the different media that you could use here. What kind of cable you are using, what kind of link layer technology you are using. That's the IP doesn't care about that. There are two versions of IP, version 4 and 6. So in CCNA, we are gonna deep dive both of the versions. IPv6, which is the latest version of IP. What are the key drivers to get to this version and all. A lot more in that there. Talking about security, if you are a designer or a policymaker for the enterprise security, these are the three overall goals. Those are there for security. The confidentiality, integrity, and availability. Confidentiality means that it's going to guarantee that the only authorized users can view the sensitive information. Using some algorithms, using some protocols and technologies, it's going to make sure that. While integrity is providing a guarantee that the only authorized users can change that sensitive information, right? It might also guarantee the data authenticity. While availability means that it's going to guarantee uninterrupted access by the authorized users. So there are ways, there are protocols, there are mechanisms and tools that you can use to make sure all three. That's the overall security goal of an enterprise. But talking about a few more things about the security, there can be a number of threats in an organization for the network or other resources. These are how they are categorized, like remote access threats. That's where when you are accessing the device from a remote access location using some tools like Telnet or SSH, you need to make sure that your traffic or the data that's being transmitted is secure. The same way, if you have physical threats, local access threats, like the people can access, attacker can access the equipment, can damage it, can recover the password, or can device can be theft at all. The same way, environmental threats, where you need to take care about the extreme temperatures, what are the recommendations for your devices that it should be operating on, the humidity, the electrical threats talk about the power supply voltage spikes, if there is any, the maintenance threats, again, talking about the if the connectors and cables are neat or not, do you have proper cabling, do you have proper labeling done to the cables or not. So that's what the different types of threats. Most of the time, you are going to deal about the remote access threats when you are accessing your sensitive resources from the campus network or the data center of the enterprise from a remote access location. Now, what can be the methods to obtain the passwords of your network devices? So one of the methods used is the guessing. That's known as guessing brute force using some tools called as password crackers. That's the attacker is going to perform systematically all the possible passwords until it succeeds. The same way dictionary attacks could also be there, where it's gonna that's a very similar to the brute force, but in the dictionary attack, it's gonna try the meaningful words to make sense of the passwords. So what are the mitigation techniques? The password management, the how you are managing your password, you are storing it, protecting it, and while you are changing the passwords for the different critical resources, it must be based on the standard procedures defined. You could also use, instead of passwords, you can use MFA, much talked about, multi-factor authentication. You can also use digital certificates or biometrics for accessing the network resources. Now, the buzzword today is automation, programmability, right? So if you look back uh, 10 years ago, 20 years ago, and if you just imagine an enterprise network that comprises of thousands of locations and more resources behind the edge devices, if you just take an example of just upgrading the software of the devices, that required lots of time, plan, and efforts by lots of engineers. Now that one task is going to be automated using different automation tools and programmability features. So basically, the automation using programmability to the ability to program the devices as well as the software-defined products like SD-WAN. You may have heard of the products like Cisco SD Access, SD-WAN, or DNA Center as part of it. So these are the automation products with programmability features integrated with those, you are going to basically provision the device, doing software management for all those devices if that needs to be upgraded. You are going to collect the data and telemetry of the network behavior. That's very important for an organization to collect the data, to analyze it, and to then to report in the meaningful reports that makes sense to the users or to the network engineers so that they can maintain the network like effectively, right? So it's going to be very important part, and we require to have separate tools to do that all, like for configuration check, compliance check that we call here. If you're doing that, then yes, we require some dedicated tools to do that. In automation here, reporting, compliance check, and yes, very important, troubleshooting, which is nothing but diagnosing the problem and then resolving it or providing a solution to that. That was a big task for the network engineers, a big headache. That's all part of one big centralized product in automation tools, right? So it's going to make the life easy. You have the templates that you are going to prepare for your for, let's say, managed devices, connecting the different locations together of the enterprise. All are going to be managed maybe just by one single template that's going to be for a specific model. Let's say I'm running ISR 4K, Cisco ISR 4K routers, then and I have got hundreds of ISR routers. So that can be managed or configured just using one single template. That's of course graphical user interface. So you are sitting on one location, and you have got one single pane of glass from where you are provisioning the device, managing it, configuring the policies, and monitoring and having insights into what's going on in your enterprise network. So that's great. That's about automation. And additionally, there are interfaces that you can use to additionally program all those devices by writing the scripts using different configuration management tools so that you can fulfill the specific needs of an enterprise, right? So that's all part of automation. In the software-defined networking, where we are talking about all these automation products, the software-defined approach is the approach where the control plane, if you are aware of these terms, the control plane and the data plane. So we are going to deep dive to these terminologies and everything in CCNA. But just to give you a quick introduction, control plane is where policy making taking place, decision making taking place, where the data plane is where actual data forwarding taking place by the infrastructure devices. So this control plane is handed over to the controller, which is on the control layer of the stack. While the infrastructure devices, infrastructure layer is where you have got all your routers, switches, firewalls, and all the devices that you have in enterprise. So basically, based on the business application needs, your applications gonna forward their need, their requirement of the infrastructure to the controller, and then controller is gonna forward the gonna configure the infrastructure devices accordingly. Now, for this to make it possible, we got APIs, application programming interfaces, which is kind of interface that's facilitating communication between these three layers. So business applications using northbound APIs communicate with the control layer, which is the controller, where the controllers are communicating with the infrastructure devices using southbound APIs. The predominant northbound API is the REST API, while the southbound API, which is predominant, is NetCom. Though we have got many others, but these are the predominant one, which is mostly being used. So this is how the three layers making intent-based networking possible. So IBN, again, is very much core of SDN, the intent-based networking, which means that the business application intent is forwarded by the control, first of all, understood by the controller, and then the infrastructure devices are going to be configured accordingly. That's what IBN means. Right, so that was the introduction to automation. We got a lot more to discuss. I know the time is limited here. That's something we are going to discuss in CCNA and all other courses. Most of the courses talk about at least the introduction of the programmability and automation, and the same is there in CCNA. Now, talking about local area networks, this is where I'm talking about a close geographical location where I have got my devices connected. That could be a floor of a building itself, or multiple buildings. So basically spanning to a relatively close geographical location, right? So that is what LAN means, local area network. And these are the components. I've got PCs, servers, IP phones, printers, or many more devices based on my business requirement. Mobile phones, we got different interconnections like NIC cards. That's the card where I connect my network cable to get my device connected to the network. Network media, we got different types of media like CAT. You may have heard of that. CAT5, CAT6, different types of category of the cables of the copper available. Then we got fiber, which is very much we have got fiber to the home concept, where I've got my fiber connection right here at my home. So it's everywhere fiber. At least the core of the enterprise, the core network, is built on the fiber, which is very fast. Again, that's something we are going to talk about it. What are the different types of media and all in CCNA more in detail. We got network devices like Ethernet switches, routers, access points to actually connect the wireless devices together. I'll be talking about routers in the upcoming slide, where we will be talking about routing, where the protocol, which is nothing but set of rules which a communication system governs. We got number of protocols. That's something, that's a single word you will keep hearing all during the all 5 days during the training, like a protocol. We got number of protocols, and you're going to play with all those protocols. One of them is Ethernet, the link layer protocol. The IP we just talked about, network layer or internet layer protocol. The address resolution protocol, DHCP. So that's to resolve the link layer address from the internet layer address, where the DHCP, dynamic host configuration protocol, is the protocol that is used to assign IP addressing information to the clients. Again, this is not the time that we are going to focus on that. That's something very much in detail discussed in CCNA, and there are hands-on lab on these protocols. This is how the different components of the local area network are connected together. So you got your wireless devices, your network printer, file server, wireless LAN controller, which is controlling all wireless devices, and endpoints all connected together using a centralized device, which is switch, and that's connected to the router that's connecting it to the outside world, whether it is internet or the remote branches or remote sites, in other words. Now, the routing is where you got two different networks, as you can see here, and those two different networks to be connected together. So if you have got two different networks, whether they are geographically dispersed or within the same campus, but we got two different networks, 192.168.1.0 and 2.0 networks, we need a router, a layer 3 device, to communicate two different networks together, right? So basically, the function of the router is to select the best path to reach to the destination networks, and then forwarding packet out those best paths. That's the two basic functions of a router. So that's one of the core topics of CCNA. We spend much of our time discussing the basics of it, getting into all pieces of details of routing. So that's what I was just talking about. We got two different networks, those to be connected together. That's where router comes in, provides this interconnection, and that's the reason it's known as internetworking device, right? So that's the routing table. That's where lookup is done by the router. If let's say that's your router A here, and there is a packet received on an interface here that is destined to 172.16.1.10 network. So that's the destination IP address of the packet. So based on the different routes, as you can see, different ports are there, like C is connected, local RIP routing information, OSPF, dynamic routing protocol, EIGRP, static routing. Again, I'm not going to talk about each of these here in this session. That's discussed in detail in CCNA, but yes, that's the route the router is going to select based on the longest prefix match with the packet that I was talking about, 172.16.1.10. That was the destination, so that's going to be the path the router is going to select, and the packet is going to be forwarded out this interface. There are other important stuff here like administrative distance, metric of it, and the next hop address. Again, each of these requires hours of discussion, right? So which is beyond the scope here. So I'm forced to go ahead to the next slide. But yes, the basic, at least one must understand that a router is a device that is used to provide communication between two different networks. It's going to select best path for your traffic to send to the destination. Now, talking about troubleshooting, as I mentioned, diagnosing the problem and then providing a resolution is what we know as troubleshooting. So though there is not specific recipes to troubleshooting, everyone has got their own specific environments in their enterprise network, and they know that if this kind of problem occurs, what can be the solution based on their best practices there. But if you are stuck somewhere, if you don't know where to go, you don't know the roadmap, that's where you're gonna follow the structured approach to troubleshooting, and that's what is explained here. You're first gonna define the problem well. That is it about what kind of problem it is? If the users are reporting that they don't have access to a specific application server, are the other users having the same issues? Is it like that particular system or the network device? So you're gonna define it well. Yes, the problem exists there. Then you're gonna gather more information about it, and that the gathered information is gonna be analyzed. And that's the point where you're gonna eliminate the potential causes. So for example, I just talked about the internet layer and different layers. So if you run a simple ping tool that is used to connect or used to test the connectivity at the internet layer, if that works, that confirms at least the connectivity at network layer is absolutely fine. Transport layer or the application layer, so you're going to eliminate that, right? And these are the methods that you can use to eliminate the problems. Top-down approach, where from the stack, starting from the application layer, going down to the physical layer, or the bottom up, where you are starting from the physical layer and then going back up to the application layer. Most of the time, used method is divide and conquer, where you start from here. Let's say you try to ping, that's where you are doing it, never clear. If that confirms you have connectivity, that means you need to troubleshoot the upper part. You don't need to worry about the data link protocols, the physical connectors, the cables and all. You need to troubleshoot the top part. Right, so that's the most of the time used. Any one of these methods you can follow based on where you are stuck. Now, talking about system monitoring, that's the first step. in understanding how a network performs is to actually gather as much information about the network problem as possible. That's where system monitoring comes in. And syslog is the protocol that's going to allow another device to send the event notification messages across different IP networks. And there are collectors, the message collectors, that's going to collect the different messages. That's the point you can basically correlate those collected events. You can look at the times, you can look what kind of problem that is, where it is triggered from, all those kind of, excuse me, just allow me a moment. So all those messages, event notifications are to be correlated, analyzed, and you can come to the point, okay, that's the problem, right? So system monitoring, that's part of day 2 operations of an enterprise. That's going to be very, very important aspect of an enterprise network management. So what are the different destinations where you can send these log messages? You can send to the buffer memory of the device. It's by default enabled to be appearing at the console line that you are accessing while you are accessing the device. You can also send these messages to the remote sessions like terminal lines. So if you have an SSH session, you are remotely accessing a device from a remote place from your PC. So you may want to send those messages, the event messages, those are triggered here to a remote device. So that's where you need to enable terminal logging on the device so that it can send the messages to the terminal lines. Syslog server is what we were talking about here, a centralized location, a centralized server where you can effectively manage all your messages. And then you can further use some monitoring tools like SolarWinds or many other tools available to actually make sense of all those event notification messages. Right, so that's going to be a very important aspect of a network management. Both of these, dealing with the configuration, copy, dealing with the software images, backup of those software images is where management of the devices comes in. So we got different types of memories, like flash memory. That's where the iOS, the operating system of the routers and switches of Cisco are stored. RAM, random access memory, is just like the RAM of your computers, where everything is running currently. And the RAM is where the startup configuration is stored. And you got a USB flash as well, where you can additionally back up your configuration. The best practices is to actually back up your software image as well as configuration to a remote server. And that's where TFTP server comes in. So you're going to copy all your configuration and the software images to a TFTP server for better management and for better storing your configuration files and software images. So if you give the command show file systems on the Cisco IS device, it's going to display you what are the different types of file systems available, what's the total size, the free available size to be used on that particular system, and the type of file system is, what are the permissions, read-write permissions, right, and their names. So this asterisk here says that this is the current default file system being used, and this hashtag or pound symbol here basically denotes that this is the bootable disk that's being used to boot this device. Now, talking about the last piece here of the presentation, which is again going to be very important for the network engineers while they are managing their devices, they must understand the different stages and the router components. Those are used in the router boot on sequence or power on boot sequence. So when you turn on your Cisco iOS device, that can be a Cisco router or a Cisco switch, it's first gonna perform post which is nothing but power on self-test. That's going to verify if the hardware of the device is absolutely fine. There is no issues with the hardware, with the interfaces, with the RAM, with the different storages I just talked about. Is it everything fine? Yes. Then it goes ahead to the next process, which is where it's going to load the bootstrap program. And as you can see, both the post program and the bootstrap program are stored in the read-only memory of the device, right? So that's the permanent storage. Even if the device gets down, that's going to stay there. So this bootstrap program is going to locate and load the operating system, the iOS, Internet Operating System of Cisco devices, Cisco iOS software that's called. So the by default location of the iOS software is Flash, but based on the configuration, it can also go ahead and connect with the TFTP server to load the software from the TFTP server, which is a remote server. Right? So that's basically defined by the bootstrap program. And then once the iOS software is loaded and ready to be running, that's where configuration, the startup configuration that's called, that's going to be loaded from either the NVRAM, the default permanent storage of the configuration file. It can be on the TFTP server. If neither of the two, it's going to give you the console of the device. That's where it's known as setup mode. That basically considers or confirms that this is the first time the device is going to be configured and used. So that's where you will be putting the initial configuration, and then you will go ahead with the rest of the configuration. Right. So that's about the boot up sequence, and that was a quick introduction. I would not say detailed. I know there should be lots of questions, considerations, doubts, but that's some of the questions. Of course, we are going to take now after my session. But yes, it's going to be discussed a lot more in detail in CCNA. And thank you. That's it from my end.
Wonderful. Thank you so much, Azeem. We are going to get into a question and answer session, but before we do that, and while you're thinking about your questions and getting them into the question panel, we're going to take a quick moment to hear from Nishad. He is our Director of Inside Sales, and he's going to introduce some promotions and webinar-related courses. Nishad, let me make you the presenter. Thank you for joining us.
Leela, thank you so much. I know time is of an essence, so I'll be very brief. I would like to thank all of you for taking out the time. Hope the brief session that Azeem took the time to walk us through was informative and it added some value to your agenda. So first and foremost, I want to remind all of us, I mean, you may not know NetCom well enough. We are a company that provides technical training and in business training all across the board, all major OEMs that you can think of. That includes Cisco, Microsoft, AWS, and various other OEMs that you may be dealing with already. Where our purpose is to promote the values of lifelong learning. So we are deeply engaged in learning and development. So I want to take a few minutes just to showcase some of the things that are related to Cisco could be of value to you. So first and foremost, if you go to netcomlearning.com, if you want to explore more, if you just go by vendor and click on Cisco, that pretty much will outline all of the courses that Cisco currently offers. But again, I'm not going to bore you with the details of the contents, whether it's a specialist or professional, certainly you can look it up. But if you have any specific question, you can inquire. We'll walk you through the specific customization. The way NetCom differentiates is customization, because what is applicable to you and your organization may not be the same to others. So many of folks might be interested in CCNA, CCNP, or specialists, or even all the way up to CCIE level certifications. We can certainly cater to you based on your need. We have a quick promotion running, just wanted you to know. It's for upcoming class that's valid till March 31st, but the usual price for CCNA is over $4,000. We are running it for $29.95 at this point. But if you are even not ready, that's okay. I want you to know there are a few benefits that you could take advantage of. One of the benefits is Cisco Learning Credits, or CLC. Now, this is a program that you may be already sitting with that you are not aware of. So you can ping your manager, or you can touch base with the person who handles your Cisco subscriptions. These are funds that are sitting at your company level for training and development that, many of cases it gets unused and wasted. So check with your organization that if you have any CLC, if you do, please ping us directly. We'll walk you through. And that each CLC, pretty much this page outlines what would it be if you chose to attend all of the value propositions, what courses, and so forth. Another thing that I want to bring it to your attention is called our Cisco subscription, which is our Cisco Digital Library, all-inclusive library. That's something if you don't have enough time to attend virtual instructor-led training, you want to do it on demand, on pace, at your own pace that you want to take advantage. Pretty much across the board, I want to quickly show you actually, this is not the page. This is the page where it outlines again, the pricing does depend on what type of and what level of subscription. So for example, if there's a networking subscription, security subscription, data center, collaboration, we also have all inclusive subscription. But again, these are all available on NetCom website that you could look up. But if you would like to have a meaningful conversation with your specific needs, we are here to assist you in any way possible. So with that, Leela, I don't want to prolong this. I wanted to take 5 minutes. I want to stop right there. I want to thank all of us for attending it. And please do reach out, as we will be providing you via email these links, so you don't have to look around. You can just simply click on the email that you will receive after attending the webinar. Thank you very much.
Wonderful. Thank you so much. And with that said, I'm going to go ahead and take back over presentation rights. And we will go ahead and get right into our question answer session. Let me pull those questions up. Our first question, which, Nishad, this is probably a little more geared towards you. Are there any certificates of participation or anything like that for today?
There's actually attendance. I mean, we'll be confirming your enrollment, but if you attend a regular class, when you complete that, then we provide a course completion certification. So if you do choose to attend CCNA, for example, at the end of the class, you will be receiving a NetCom certificate. But if you do want the Cisco one, obviously you have to sit for the test and the exam.
Wonderful, thank you. Okay, then our next question is, what is the difference between bandwidth and speed?
Hey, that's for me. That's a great question. Thank you for the question. Could you please make me presenter back again?
Yes, definitely. Great. Okay, you should be able to share.
Okay, thank you. I hope my screen is visible now. Okay, so bandwidth. Yes, okay, thank you for confirming. So as I mentioned, bandwidth is the maximum data that can be transmitted over a link in 1 second. Right? So if I'm talking about a router, it has got an interface which is 100 Mbps. That means that's the maximum size of data that can be transmitted over a period of 1 second out that interface. Whereas speed is the how fast a single bit is transmitted from this source to a specific destination. That depends on kind of media you are using, what are the intermediary devices, how they are behaving, what are the protocols configured. So the speed, how fast a bit is transmitted from source to destination, where the bandwidth is the maximum size of data can be transmitted over a period of 1 second by the link. I hope that answers the question.
Yes, thank you. Let's see. Our next question is, what are the algorithms used for confidentiality and integrity?
Another great question. For confidentiality, that's basically where we talk about the VPN technology, right? So virtual private network. So how we are gonna make sure that the data being transmitted remains confidential? Yes, that's a great question. We are gonna use some algorithms for the same. Those mostly used algorithms are AES, Advanced Encryption Standard, and the triple dash data encryption standard, seal, and there are many more. These are the mostly used one for providing confidentiality, for integrity in the VPN. We mainly use SHA, which is secure hash algorithm, and there are different versions of it, like SHA-2, 256, and many more. We got MD5 as well, but that's not recommended to use due to security reasons, right? So SHA is going to be the algorithm mostly used to provide integrity. Okay, that's it.
Thank you. Okay, so our next question, I'm just watching time. What is the difference between OSI Model 7 TCP and IP model?
Okay, that's great. That's another great question. OSI model, the Open System Interconnection model, and the TCP/IP model. That's the question asked. So OSI model was the standard model that was used by the devices long back in 80s and 90s. But then later on, Department of Defense, US, DoD, developed TCP/IP model. From that point on, it was initially developed for military use only, but then later on, it became the standard for communication. Then from that point on, OSI remained a reference model. That's why it's known as the reference model. So for all the developments, research and developments, we are referring to the OSI, where the actual model in action is TCP/IP model. That's one of the main differences. The other is that we got 7 layers in OSI model. In TCP/IP, we got 4 layers. From the functionality perspective, both are same. Like the upper 3 layers of the OSI model are merged together into 1 layer. That's the application layer, where 1 layer is renamed. The network layer of the OSI model is renamed to internet layer of the TCP/IP, where the functionality remains same. Then the bottom 2 layers are mapped or merged into 1 layer known as link layer. Right, so I hope that answers the question.
Thank you. Okay, it looks like we have a few more. And we do have time for a few more. What is the difference between latency and ping?
Latency and ping. So is that right? Latency
Yes.
and ping. Okay, that's great. So ping is a tool that is used to test communication connectivity to the destination, where latency is one of the parameters that we use in the in testing the communication. For example, let's say if I'm sending some ping messages from a source to a destination. So let's say from one part of the world to the another part of the world to the destination. So I'm going to use a ping tool, which is used to test the connectivity, where latency is going to display me the time taken for the packet to travel from source to the destination, one-way time of the packet. So simply the time a packet takes to reach from source to destination is latency, right? It is also known as one-way delay. While the round trip time, the round trip delay is the time taken by the packet to go to the destination and come back, where latency is the one-way delay. I hope that answers the question. Both latency and delay are actually part of the ping or many other tools. Those are used to test the connectivity at different levels.
Thank you. Okay, our next question is, how do you define packets?
Packet. Packet, if I am allowed to go back quickly at the OSI layer or the TCP/IP stack, which is here. So when you are sending the data, let's say you are a user here sitting on the top of application, you are sending some sort of data. Let's say you are accessing your bank server. So that's known as HTTPS data. So that data, the user data at the application layer and the transport layer and the internet layer on the link layer, all the layers have got different form of data. Okay. So that's known as PDU, Protocol Data Unit, the form of data at each layer. The form of data at the internet layer is packet. So basically, each layer, starting from application, then transport and internet and link, are going to add some additional information to the data that was originally sent by the user, right? That makes different forms of the same data at different layers. And the packet is the form of data that's known at the internet layer. Again, it includes a lot more information like what's header it's gonna contain, what are the different fields of it. But yes, the form of data and at internet layer is the packet. That's it. I hope that answered the question.
Okay, we got about 3 minutes left, so we're going to take 1 or 2 more questions, depending on how. Oh, sorry, I've got to sneeze. Oh, there's another one. I am a bit confused to clearly understand the difference between SD access, DNA center, and SD-WAN. Can you please clarify those?
That's again a great question about the software-defined networking. So software-defined networking is an umbrella term. That's a technology. On the basis of this technology, we got multiple products. So the 2 products on this technology is SD access, which is used to provision, manage, and monitor the all the devices except the edge devices, the WAN edge devices. Okay, so it's gonna basically manage all your switches, access points, wireless LAN controllers. I'm not gonna mention, there are many more, where the SD-WAN, as the name says, wide area network, it's gonna manage all your WAN edge devices. That's basically representing different sites of the enterprise. Right, so the SD-WAN is one of the products of the SDN technology that's going to manage or automate your wide area networking, where this is for campus network, in other words. The DNA is nothing but the controller that's used to do that all for SD access product. So DNA in itself is not a different solution. It's part of this the SD access, but that's the controller that's gonna manage this solution. Where the SD-WAN has got its own controllers, like vManage, vSmart controllers, vBond, and many more. Again, that's a absolutely different discussion. Okay, so these are the different products of the same umbrella technology, which is software-defined networking. That's it for the question. Can you hear me?
Yep, we can.
Sorry, I was talking and I had myself muted because I didn't want to sneeze in the middle of your conversation. So yes, thank you so much for joining us. With that, we are actually out of time. So even though we could get to some more questions, we are going to have to wrap up. We want to thank you so much for joining us here. And with that being said, we're going to go ahead and launch a quick poll to find out how many people might be interested in taking some additional training. So please give us feedback feedback on that. It always helps us to kind of know what you're enjoying with these webinars. In addition to today's webinar, we have a lot of informative webinars coming up. So please go to www.netcomlearning.com/webinars/ to register for any of those. And we want to thank you all for taking time out of your day to join us. If you do come up with any additional questions, please feel free to send them to us at webinar@netcomlearning.com at any time. We hope that you found today's webinar to be very informative, and we look forward to seeing you all back here with us very soon. Also, feel free to tell your friends and colleagues about our webinars and other courses. Once again, thank you everyone, and have a wonderful day.